Okay, I think we'll get things going now. So welcome to the first in a series of Cirrus Link webinars. Today we'll explain how the lightweight publish-subscribe messaging protocol, MQTT, can help you implement your IIoT solution to achieve a digital transformation. My name is Chris Houghton, and I'll be serving as the moderator today. With me is Arlen Nipper and Kurt Hochanadel, who'll be taking you through the details of this webinar. Arlen, can you advance the next slide?
We're there.
Great. Kurt, Arlen, and I have worked together for over 20 years in this industry. When back in 1999, Arlen had the good fortune to work with Andy Stanford Clark at the IBM Research Labs, where they co-invented MQTT to solve a real-world problem, sending oil and gas pipeline data securely and reliably over satellite communications. Today, MQTT is the most widely used IoT protocol because of its ease of implementation, security, reliability, lightweight design, and above all, its open source availability. Cirrus Link Solutions was founded in 2012 by Arlen and myself and has over 70 man-years of experience in-house implementing solutions using MQTT. We are one of only 2 strategic partners to Inductive Automation who created the Ignition platform for SCADA and MES. Our MQTT modules enable the Ignition platform to connect OT data to IT services for big data analytics while providing a superior OT solution. We've worked with over 35 OEMs to help them implement MQTT Sparkplug either natively or by embedding Ignition Edge MQTT on their hardware. In this hour, we'll provide an overview of the MQTT and Sparkplug B, and then dive into each of the MQTT modules, explaining its use and function in the Ignition platform, and how the MQTT and Sparkplug B can simplify your digital transformation. We'll then have a live demo and wrap things up with a Q&A session. So if you have any questions as we go through the presentation, please post them in the chat window and we'll answer as many as possible at the end. And any questions we cannot get to, we'll follow up directly with you after the presentation. So without further delay, I'd like to hand over to Arlen Nipper, President and CTO of Cirrus Link and co-inventor of MQTT. Over to you, Arlen.
Thank you very much, Chris. And I thank everybody for taking the time today to join our webinar. I hope it's informative and interesting for you, and hope we can go forward, we can look at this technology. So we'll start out, we just want to do an overview very quickly, a high-level overview of what is MQTT. Well, MQTT is simply a specification that describes how to implement a message-oriented middleware solution. So by message-oriented middleware, we already know that IT are very familiar with decoupling their applications using publish and subscribe technology. Case in point is the fact that AWS IoT, Azure IoT Hub, IBM Watson, and Google Cloud Platform all use MQTT in their IoT and IIoT solution sets. But the unique aspect of MQTT and what it was originally designed for was real-time mission-critical SCADA solutions with the following design goals. One is that this was in 1998-1999 timeframe, and it had to be simple. We were on 8-bit microprocessors, we had limited amount of RAM, and one of the aspects of this when we first started looking at it is, do we use UDP, do we invent our own wire protocol, or do we leverage TCP/IP? Now you have to realize in 1998, TCP/IP was really kind of unknown within the operational technology realm. But we did decide to do that, and looking at it now 20 years later, it was a very good decision that we made for that. Second of all, it had to be efficient. We were doing this for VSAT-based real-time SCADA systems, and bandwidth cost a lot of money. Third, it had to be stateful. In other words, to control pipelines, open and control valves, start and stop pumps, we needed to know the state of all those devices that were connected into our infrastructure. Were they available? Were the tags fresh, or was the data stale? And then lastly, I had already been in the industry for about 20 years, and I figured out that with all of these proprietary protocols, or protocols that weren't very well documented, that it would never take off. So it had to be open right off the bat. Now, I'll just mention here very quickly for those of you that are interested. Now, MQTT enjoys two international standards. One is an OASIS standard, and two is an ISO IEC standard. And you can look up the standards there, but that's where you would find all of the detailed information that we're not going to go into today. Now, kind of a timeline here is that 1998, 1999, Andy and I worked with the Phillips 66 team, and we designed MQTT, and the first specification was published in 1999. It was all of 18 pages long. Now, it was kind of sequestered or relegated to IBM only solutions for a very long time, because really they were the only company that had all of the tooling and the message-oriented middleware pieces that we needed. But something very interesting happened in 2011. Facebook blogged out that they were picking MQTT for Facebook Messenger because of the efficiency and the ease of implementation. Well, that kind of started a bit of a landslide, and in 2012 we started the Eclipse Tahu project, which open sourced a lot of this technology so that people could get their hands on it. 2014 we got it into the standards bodies. Now, 2016 was very interesting because, like I said, up until this point, this technology was rather sequestered. But now, in 2016, we became a strategic partner with Inductive Automation, and then we started to be able to take this technology and put it into operational systems. Shortly thereafter, we started the Sparkplug specification, and as of last year, we started the Eclipse Tahu project, which makes everything that I'm going to talk about today with regards to Sparkplug open source and available. Now, if we look at just what is the breadth of, if we're going to pick a technology going forward, then we've got to make sure it's going to be around. This is one of the slides from the Eclipse Software Foundation. They've been doing this survey now for 5 years, and I would invite everybody on this call. They've got the 2019 survey up on their website today, and I would encourage everybody on this call to go fill out that survey, because we get a lot of really valuable insight into not only transport technologies, but the industrial Internet of Things at large. So you can see here that one of the very interesting things to me is that in 2018, MQTT became more used even than HTTP. And if we look at the adoption curve, we can see that, from the accelerated growth of MQTT, it really is becoming one of the major IoT transports. And how do we leverage that? So let's go really quick through how does this work in a real world implementation. So there's two pieces involved in an MQTT infrastructure. One is you've got to have an MQTT server, and the other is that all of your devices or your solutions implement MQTT clients. Now, the first thing that's interesting to note is that a client makes a remote originated connection into the infrastructure. That means that that's a remote originated connection, and I don't have to have any ports open out in the field. So from a cybersecurity footprint standpoint, that's a huge advantage. Now, the next thing that we do is we create what we call an MQTT session, and in that session, we provide our username, our password, and our last will and testament. Now, you know what a username is, you know what a password is, but what's this notion of a last will and testament? Well, as I mentioned before, MQTT had to be stateful. And that last will and testament is held by the MQTT server until, at some point in the future, we lose our connection. And when we lose our connection, in real time, a death certificate is published on our behalf because we're no longer on the network. And any other application that's interested in our current state subscribes to that death certificate and is immediately notified when we fall off an IP network. So we create a session, And then once we've created that session, we publish information on what are called topics. So I could publish temperature and pressure on a topic called process variables from a PLC. And I can subscribe to information that I'm interested in. So if I was a PLC, I might subscribe to commands. So at this point, we have a complete MQTT infrastructure, but it's not very interesting yet. But if we were to add another component, let's say we had another client and it did the same thing. It connected, established its session, but then it subscribed to all of the information that I was publishing. So now my temperature, my pressure, my flow rates, whatever information I might be collecting locally and publishing, that client will immediately get that information once he's subscribed to it. Also interesting is that client can publish information on a topic that we could define that says, okay, I want to publish a valve open command, and my client out in the field has subscribed to that. So the other interesting thing here is I could add 2 more clients. One, they could both subscribe to all that information. So all of a sudden, we have a one-to-many architecture that can publish and subscribe data in real time with state awareness without having to have any ports open out in the field. So as we build out, we have clients that publish interesting information, clients that subscribe to that. And what we end up with is a stateful, secure, again, we don't have to have any ports open out in the field, real-time SCADA infrastructure. Now, one of the things that I noted is that one of the reasons that MQTT, I believe, has become so dominant in the market is that it is super simple to implement. You can publish anything that you want on any topic. You can publish a JPEG picture, an XML document, a JSON document, a binary message from a Modbus PLC. But the problem is, as we started looking at it in the industrial space, is you could publish anything that you wanted on any topic. So about 3 years ago, we started thinking about if we really wanted to use MQTT in a mission-critical real-time environment, we at least need some standards that everybody can agree upon. So what Sparkplug set out to do was take and define a topic namespace that made sense in the industrial sector. Number 2 is to define an efficient binary encoded payload for process variables so that we could not only use this on high speed, high bandwidth cloud computing, but we could use it all the way down to radio communications, VSAT, cellular, and still maintain our efficiency. Finally, we defined that state management that I told you about, in that once we have our last will and testament registered, now in a real-time SCADA system, we're very concerned about knowing the state of every device in real time. And we went through some discussion around high availability, redundancy, and scale. Now, then in 2018, we took all of this and all of the reference implementations that we did in C, Java, JavaScript, and Python, and we donated all of that to the Eclipse Software Foundation, and now lives in the Tahu project. One of the notions that we have here is that, if we look at the Internet of People and how that has taken off in the last 30, 35 years, and what drove that? And what drove that were 2 available open source technologies, a transport HTTP and a representation HTML. Then as we migrated in towards machine to machine, towards the Internet of Things, a lot of people started adopting MQTT because it was very efficient and it was very lightweight. But as we transition towards the industrial Internet of Things, we need to have a definition of what is it that we're publishing over that MQTT transport. And I believe that's going to be Sparkplug B. So if we can get to the same adoption of the Internet that exploded the Internet of People, I think that will explode the adoption of the industrial Internet of Things going forward. So what we're going to talk about is the 3 core modules for those things that I just showed you. A client, the host client is MQTT engine, is a module for ignition. MQTT distributor is that MQTT server that we showed you a while ago. And on the edge, MQTT transmission is that edge client. So as we look at using ignition and its tooling and all of the capabilities Ignition already have. With those modules, we can take and we can have an MQTT server sitting in an Ignition gateway. We can add a host client to that. And then at the edge of the network where we need to start interfacing to that brownfield equipment, we can add the edge clients. So if we look at those product names again, we've got MQTT distributor plugs in as a module on our Ignition gateway. Now we've got an MQTT server component. We need one of those MQTT clients to subscribe to some information that we're publishing from the field. So that's the MQTT engine module. If we look out on the edge of the network on Ignition Edge, now we've got all of the OPC UA protocols that Ignition already provides and all of the tooling it provides, but we've got the MQTT transmission module to be able to take that information and publish it using that Sparkplug definition that we just talked about. So taking all that into consideration, an overview of what is MQTT, what is Sparkplug. Now I'm going to hand it over to Kurt, and he's going to walk you through how we apply those in digital transformation solutions. So Kurt, over to you.
Thanks, Arlen. So how this applies to digital transformation and what I'm really calling is industrial digital transformation. I think the first thing we need to do is kind of define what this means. So an aspect of what we call it for here, industrial and digital transformation, is the application of digital capabilities to processes, products, and assets to improve efficiency, enhance customer value, manage risk, to innovate and discover new opportunities. It enables insight across the enterprise, value chains, enhances competitiveness, and improves customer experience. So that's kind of a broad-based look at it. It's kind of really wide-ranging across the whole business enterprise. From an industrial standpoint, really what this means and what the main requirement is to actually get this done is data. So the IT tooling sales pitch is typically, as seen on the picture on the left here, as a proposition. All the services and applications to render insight through big data, AI, machine learning, the digital twin, etc., and so on. You have all these services that you want to enable and use to garner that insight. However, in most of these applications and cases, what you typically see is you see all these services and all these applications that you can use, and then you have this little small arrow from the OT world say, hey, just connect your data. And seems to be simple enough, but the reality is the picture on the right. Most of the work is identifying the right processes to get the OT data to the IT tooling. This is typically called bridging the OT IT gap and connecting the brownfield device data to these processes. This is where the work starts, dealing with these industrial processes, the protocols, the security, the data representations. There really are no standards on this process, and this can quickly become a cost deterrent to moving forward with any implementation. So let's start here. The digital transformation journey starts with the operational infrastructure and then putting together a migration strategy that implements the digital transformation, but also has to meet all the OT requirements. The majority of your digital transformation will be with a brownfield world. This is going to happen for more than a decade. People are not going to replace all existing devices to a new IT standard. The costs are just not there to get the benefits. So what does this mean? So what do we have to deal with in this current environment? Well, we'll have to deal with poll response protocols. We'll have to deal with physical interfaces such as RS-232, 485, radio, cellular, satellite. Lots of existing OT environments that maybe the IT world is not really ready to consume. There'll be proprietary SCADA systems, silos of data. There will be device expertise and tribal knowledge on each of these systems that are regulated to hurdles to making this happen. There'll be all sorts of data formats and can have non-standard security. So this is what we're looking at, and this is what we have to address to actually begin and simplify the digital transformation. So if you take a look at the picture on the right here, this is an actual project that we're working on. And we're connecting to a 20-year-old flow computer. Not new products that are out. This is kind of the brownfield environment we have. It uses a version of Modbus, and it contains critical information that can be consumed by big data to gain insights on improvements. So looking at the piece of data, so what does this mean? So let's say there's a Modbus address 40,027, and it equals 1256. So what would IT do with this? What does it represent? Is it a raw value or is it scaled? What are the engineering units? What's the engineering range? And really, what is 40,027? So in this sample, it could be compression temperature or tank level, and it could be, PSI, or inches or feet. But this is what the OT world looks like. And so you can't really transform this and make it easily IT consumable unless you have a data standardization to do this. So given this, let's take a look at some of the considerations to do digital transformation. And what you want to do here is, how do we look at this holistically as a process across our enterprise and addressing at all levels to implement this? So first is connectivity, and this is kind of a broad level. So in doing digital transformation and looking at a company's assets, I need to connect it from a sensor level to a device level and then to an application level in the OT environment. It has to be able to solve each one of those solutions. It can't be a different solution for the many types of projects you're dealing with and having custom applications for each one that's differently. It just becomes cost prohibitive. You need to be able to support multiple protocols. It's like Modbus, Allen Bradley, EIP, DMP 3.0, Siemens, and etc. It needs to have an ease of implementation. You need to have tools on platforms and not custom code or applications on product. If you have a custom code and on each different application you go in, the hurdles are just going to be too high to actually even start the process. It needs to be platform independent. It needs to be able to run on Windows, on Linux, Mac OS, a No OS, a microcontroller. It needs to work for all those different solutions. You want to be efficient with bandwidth utilization, so they can run over cellular, satellite, or constrained land environments where it's already too congested. It also needs to have cloud connectivity to go to AWS, Google, and the different cloud platforms. And I think a key component is that this solution really needs to come from the OT world and not where the tribal knowledge and the understanding is, and not from IT down. It needs to come from OT up. So the second point is the decoupling. This is how MQTT helps. When you implement this, you do not want this data to be tied to a proprietary solution in which they own the data, the format, the services for the application. You yourself as an organization want to have a decoupled solution in which you can choose and pick whatever application, new application, or services that are available to instantly provide access to. You cannot do that in a serialized proprietary solution. You want the data to be broken free out to the enterprise. This means you also want to have it to have the capabilities of auto discovery, in the sense when I add new devices on the line or I change modifications at the edge point, that those changes are immediately related across the enterprise. So each application that is subscribing to this information or needs this data understands that changes happen or a new asset is available. And it also needs to have a source of truth as far out at the edge of the process as possible. So that's where the knowledge base is of the actual data points. So if there is a new analog added or new things are changed, and you can provide context at the edge, that then can be pushed and promulgated throughout the enterprise. The other format, other consideration is the data transformation. I think this is kind of key from a holistic standpoint, where you want to standardize on, how do I want to represent this data that can be easily IT consumable? And providing a standard of that is going to be critical, be it a sensor or be it a SCADA solution. This means that you have, tag naming capabilities, changing that Modbus address to mean an actual compressor temperature that an IT understands how to consume, knowing that it's scaled from 0 to 100 PSI, and that they can utilize this information in their AI services relatively quickly. So this is all the scaling, the engineering units, and the data format. And the last point you want to have consideration is for security. On this, we think you should utilize the latest TCP/IP security technology, like TLS and things of that nature. You do not want to have a proprietary security schema to where you're not using the standards. So as standards change, you can follow along with the TCP/IP standards and just layer that on top of your data delivery mechanisms. So you're never at all caught in a scenario where you cannot adapt to new security requirements. So now let's look at these, take these considerations and apply it, to MQTT with Sparkplug and the Ignition platform. First, with MQTT, the solution is decoupled. The data is not owned by any one application, and it can be consumed by multiple applications. With Sparkplug, you have an open standard in which data is expressed that has the context to make it easily IT consumable. It also provides the auto discovery mechanisms as new data assets are added or modified, requiring little human interfacing for this process. So let's look at the different levels of how this can be connected. Looking at the sensor and device level, sensors can be adapted to support MQTT, as many already do, utilizing the Eclipse Tahu client, and they can implement the Sparkplug topic naming and payload specification. An example of this can be seen from the Easy Automation Easy Rack PLC. The Easy Automation used a GitHub repository and a Sparkplug specification to develop an MQTT client on their PLC. With this, any tag or register can be sent through the MQTT and consumed by an OT and the business enterprise. So they went through, didn't take them more than a week or two to develop this, a little support that we support a lot of OEM customers. Now their PLC, their ladder logic, and all the tags created can easily be dropped and consumed by the enterprise. With Tahu and the Eclipse Tahu client, with the Sparkplug specification, any OEM device manufacturer can start developing this. What's kind of interesting is we have our clients and customers that are currently using MQTT. They're making this a standard for the OEM manufacturers if they want to partake in bids and processes, that they actually follow along and utilize this. And now I realize it's an open standard. It's free to use. There's no cost. It's just a implementation that they would have to do. So that's at the sensor level. So I can have a sensor doing it. I can have a low-cost device doing it without no other software. It's open source and pretty easy to use. Now let's look at the edge gateway level. When I say edge, this could be on a pipeline, it could be on a substation, it could be a group of sensors in the factory floor, or the factory itself. As like the Ignition platform, Ignition Edge here has no tag limits. I mean, you can have unlimited tags utilizing the Ignition Edge. The only limitation will really be the hardware limitation on what's the limitation of tags you could actually utilize in a process. This is where the Ignition Edge, with the use of the MQTT transmission module, provides the solution. Ignition Edge software can run on many different platforms and provides a tool that configures connectivity requiring no custom code. It has a set of protocols to connect to assets, create tag naming and metadata, and provide the context to make it IT consumable. The transmission module on Ignition Edge converts the OT tags into the MQTT Sparkplug data using report by exception for efficient bandwidth, and utilizes store and forward capabilities in case of network failures. On the store and forward, this can be in memory or hard disk. So if there's a failure in the network, let's say there's a failure at the MQTT server level, it will initiate and start storing all of the change events that happen on these tags. So in those circumstances, to do your analytics, you don't lose any data. When the network comes back online or the broker comes back online, the data is published with all the changed data at the timestamp when that happens, and they can backfill in a storing or a process. So you get better AI analytics and don't lose data. So some examples of this is you have the OptoGroove Epic box here. They're on the Ignition Edge onboard program. Ignition Edge is running on their Opto22 Groove Epic. So it can connect the I/O modules that it's currently plugged in as a PLC or an RTU, but also to other devices that it's polling. With this, it now can connect that data to MQTT and Sparkplug. The second one is a freewave radio called a Zoom Link. It's a 900 megahertz radio. So a lot of oil and gas wide area radio networks has this. You can now implement Ignition Edge. It runs on that platform. And so with that radio at the endpoint that you're talking to devices, it can use that license-free 900 megahertz spectrum to publish data from that type of scenario. Then you can have a Moxa UC8100. It runs Ignition Edge. It's a cellular router, a cellular gateway. So if you're dropping assets out where you just need to drop it in and connect to devices, you can drop cellular in. It can connect to those devices using Ignition Edge with a very bandwidth efficient communication standpoint, have lower cellular cost, and have the security to connect this data not only to your OT solutions, but also to those business enterprise solutions to do gaining the insight. And also you can have customers that have gateways as a product, like Red Lion. One of their HMI panels supports Sparkplug natively. This does not use Ignition Edge, but it can connect to those data assets and provide it as well. So now going on to the third aspect. This has covered the sensor level, the edge gateway level. Now let's look at the factory floor. For any existing Ignition system, one would only need to add the MQTT transmission module, and all the tags within the Ignition system are now available to be consumed with MQTT infrastructure to the business enterprise. So looking at the top level, if you already have Ignition, just adding one module and this data can start publishing out MQTT and can be consumed. For existing SCADA systems that are not Ignition, when you purchase the MQTT transmission module, it comes with the Ignition platform. This includes the OPC-UA server module, so that if most of your, let's say, existing platforms support OPC-UA, you then can connect all that data into Ignition, provide tag naming, and just with that one module, you can now push existing SCADA data into that enterprise. This is also the case when you are looking at an OPC-UA server. This could be a Kepware or Matricon. Again, all you need to have is that one module, and you can connect those assets. To give you an example of some of the things how we're doing this, we have one customer that has I think about 65 plants across North America, of which each of the plants have anywhere from 40 to 100,000 tags, and they have Ignition, they have some existing SCADA. They drop this in, they take the MQTT module, and of those tags, of the 100,000 tags, each of those tags are changing about 40% per second, up to 60%. So the transmission module is taking all that information, reporting only the changes. They have it going into a central infrastructure in AWS where this data is collected and then pushed into a cloud service provider to start looking at analytics. So from a standpoint, the MQTT provides the connectivity. It only puts the change data in, connects it to the infrastructure relatively easily, provides all the context, and makes it easily IT consumable into AWS cloud services for their analytics. So it's quite easy to implement. And if they have a new plant, a new application, a new sensor, a new device, you can start adding those as a standard across with a standard format. So let's look at this from how it's simplified. Utilizing the Ignition, the MQTT modules, Ignition Edge, and the Eclipse Tahu project or Sparkplug implementation, this now standardizes the OT data across your enterprise to make it easily IT consumable. It's a solution on all levels, from the sensor to device to the factory floor. It has easy migration and quick installation. You can download this and install it in minutes and start trying it for free. It is tools on platforms. This is not custom code. The investment you need to get started on this is small. You can do this for free. Just use your time and download the software. There's no need to spend $100,000 to even start getting this. You can start doing this today. It's very cost effective and modular. You can just add one module to an existing system. Ignition Edge can go out to start bringing some assets in. You can, migrate as you need to. There's no, I have to do everything at once. This gives you a very simple approach to modularize the solution as needed. It has unlimited tags. No matter if you're using Edge, there's no huge cost associated with it. And it's using the open standard. It's secure. MQTT is using TLS security. It's outbound originated, as Arlen said. And with Ignition, you also have cloud service connectivity to the different cloud platforms, to which if you want to start utilizing IBM Cloud, Google Cloud Platform, Microsoft Azure, or AWS, you can instantly do this just by dropping a module in. So when you combine MQTT with Sparkplug and Ignition Platform, it truly simplifies and standardizes digital transformation from OT to IT. And with that, I will now give it over to Arlen. I think he will be doing a demo.
All right, thank you very much, Kurt. So real quick, this is the infrastructure of the live demo that we're going to show. So on the right side, this is most of the equipment that we actually have in our lab. It's a great lab to play in if you like hardware. In addition to that, we have 1,400 swarm simulators coming in. So all this infrastructure is there. It's connected into 3 MQTT servers that are running up in on a virtual private cloud, through all using TLS connectivity. And then on another Amazon instance, we have the Ignition platform running. So that's what we're going to take a look at right now. So first thing we'll do is we'll open the console to that Ignition gateway and just see what we've got there. So if we look at our modules real quick, if you're familiar with Ignition, we've got all of our standard modules installed, and we've got some Cirrus Link modules installed. Now, the ones that we're interested in today are distributor, our MQTT server, and MQTT engine. Now, we do have upcoming webinars for all of these other modules, the cloud connectors and things like that, so stay tuned for upcoming webinars. Now, for MQTT engine, once you install that on your Ignition platform, you get a settings tab. Let's go over here. And really what we're interested in is that we're telling Ignition that there are 3 MQTT servers out there in the world somewhere. They could be on-prem, they could be in the cloud, they could be both. But really, we're just interested in saying, okay, Ignition, here's some MQTT servers. Now also note here that we don't have engine enabled yet, so we don't know about anything. So now let's open the designer for this instance. And in the designer, again, when we installed MQTT engine, we got a new tag provider called MQTT engine, and it's got a folder here called Edge Nodes. And those Edge Nodes should tell us about everything that's in our infrastructure. So if we look here, we actually did a dashboard where we took those Edge Nodes and we said, okay, well, here's how many Edge Nodes we know about, and here's how many devices we know about, and here's how many tags we know about. Well, since we're not plugged in, we don't know about anything. So part of what we just discussed about MQTT is we can plug in, we can subscribe to things, and it's kind of self-discovery in that we can figure out what our infrastructure is, and we should be able to do that very efficiently. So let's go back here real quick, look at the status. And I can tell you right now, we have 311 tags in this system. Those are system tags. And so I'll ask the audience here, how long would it take you to configure, just configure, let alone add all the metrics, configure over 1,400 PLCs and over 60,000 tags? So what we're going to do is we're going to go into MQTT engine. Now in this dashboard, this ignition dashboard, I've got a template repeater that it'll graphically show devices. They show up as little green squares, and you'll be able to keep track of the online devices and edge nodes. So let's plug into the infrastructure and see how long it takes us to learn this infrastructure. I'll enable engine, save the changes, and we'll just watch. And boom, about 10 seconds later, if you guys had a stopwatch on that, we just learned over 1,400 devices and 60,000 tags, and we did that in a matter of seconds. Now, if we go over to our engine folder, we refresh it, we can see that now we've got folders under here for Advantech devices and FreeWave and Opto22 and Moxa. We're talking to Allen Bradley PLCs and Modbus PLCs and flow computers out in the field. If I open this up, I can see that this FreeWave radio just came online, and it's talking to a Zoom link to a Modbus PLC. I can see here that I'm connected to a Rockwell flow computer. So all of these tags, and if we go back and just kind of look at that very quickly and say, okay, how many tags we'll go back to our status. And in ignition, we now know about 58,934 tags. Now let's take a look at what we discovered there. Well, one of the things, as Kurt said, is that we have a Moxa 8100 running Ignition Edge connected over a Verizon cellular network. And note here that we've got that Ignition Edge polling 5 Modbus TCP devices. And we've got the digital outputs on those devices tied back to the digital inputs. So if I get into command mode here, we discovered all this information automatically, came up, and now we can come in here and we literally can pick a digital output, and we've got the digital inputs wired back to the digital outputs. So we can publish a command, turn on that digital output, scan it using the Modbus driver that's already in Ignition Edge, and now we're able to get that information back very quickly. The other thing here that for this demo that we like to show is that I've got some analog inputs and some RTDs that are floating, but I've got an Ethernet switch right here in the network. So it's powered by relay output number 4. So if I turn off output number 4, that's going to cause a failure out in the field. But because of Sparkplug, we were able to publish the fact that those two devices just dropped offline and all their tags went stale. Now, at this point in time, I want to show you the efficiency aspect of MQTT is that I'm going to reset my communication statistics. I'm polling at the edge at 250 milliseconds. But notice how much information we're publishing over the cellular network. None. Because with MQTT, we have state. If we have state, we don't need to keep publishing information that hasn't changed. But as soon as I send a new analog set point, say send a new value of 512, that caused the publish go out, and we immediately got that information updated. Now, we'll go turn that Ethernet switch back on, and what's going to happen is we're going to poll those devices, find out that their device status came back online. As soon as we get all the tags, we're going to publish those, and we're back online. Now, let's look at it from the other aspect that we said is that this is the performance and the efficiencies of MQTT. Well, let's take a look at the single source of truth. So we found a device, we called it IA Group, Ignition Inductive Automation Group, running Ignition Edge. It's talking to a click Modbus PLC. Now, I would expect if I open this folder, I'm going to get Modbus registers, but I actually get tag information that's quite interesting. So if I look at this tank 115, I see that, oh, not only is it a tank, tag name, it's got engineering units of meters, engineering low of 0, and engineering high of 30, and it's actually got some descriptive information. So I built a dashboard that took that single tag, and again, remember, we discovered this in less than 10 seconds. We were able to put up a tank graphic that said, oh, I know that this is tank 115, it's got gasoline in it, it's at 53%, or in other words, it's 16 meters, and the temperature is 63.01 degrees Celsius. Now, let's take and look at Ignition Edge. And this is the console for Ignition Edge. Now, this is running on a Raspberry Pi. And if you'll note, my tag structure is identical on the edge as to what it is over here in my Ignition Gateway. So what I was able to discover in just a few seconds and publish was all recognized by the Ignition Gateway, and I can immediately start using those tags. Now let's take a look at that. Let's go into that tank 115. And I can look and I say, okay, I can see it is coming from my OPC polling engine as a nebulous V10, but I called it tank 115. I could go into my numeric properties and say, I'm going to scale 0 to 4095 to 0 to 25 somethings, and I'm going to call those somethings in meters. So what we're going to do here is we're going to go in and say, well, we're going to scale that 0 to 25, which I already had in there. And we're going to go 0 to 25 here. And we're going to call this, since we're in Kansas City, let's call this Boulevard IPA to make it interesting. And let's change the engineering units to feet. And we'll remember we did that. And while we're at it, we're going to go into the tank temperature, and we'll change our temperature to, let's say, degrees Fahrenheit. Okay, and now what we're going to do is we're going to go in and refresh this by just republishing all of that information. Now what it's going to do is scan it, and now if you'll look at the tank, you'll see that it's 0 to 25. It now has Boulevard IPA in it, and my temperature is expressed in degrees Fahrenheit now. Now notice here that my oil pressure was kilopascals, my RPM was already scaled for what my RPM values were. It was a value of 0 to 2000. So what we're showing here is the ability to provide single source of truth. The other thing that I really like with this is that we always are dealing with enumerations out in the field, whether they're flow computers or machines out in the field. Well, look here, what I've been able to do is take what was an integer value that was an orifice material enumeration. That's a number, 0, 1, 2, 3. But you guys in SCADA, you know that somebody's going to call you at 4 o'clock in the afternoon and say, hey, Joe, can you look up that manufacturer and tell me what the enumeration is of a number 2? Well, we can use the tools in Ignition to take that, do an expression tag, and actually provide contextual information. Stainless steel, Monel, carbon are the enumerations for that. So now, if I change my material enumeration from a 2 to a 0, you'll notice that what we published was stainless steel. Also, if I exceed that or put an invalid value in of 10, says, oh, that's a material enumeration error. Now, that shows some of the power of having those tools on the edge. Now, finally, we'll look at a lot more complex. Now, we're not going to go into a lot of detail here, but remember I told you the other thing that we found automatically was that we had a very complex device, a flow computer. And in the flow computer, if you guys are familiar with them, they have very complex setup. There's a lot of parameters that have to be configured. And to build a dashboard and discover all these tags and discover all the engineering units would be a large job, let alone the fact that we learned this in 10 seconds. But now that we did that, we used a tool within Ignition called a UDT, a user data type. With that, we were able to build a template. So if I wanted to build a very complex screen just on discovery of this tag, watch what happens. I take that UDT, drag, drop it on my screen. Oh, look, I've got a complete dashboard of that entire flow computer, and now I can actually send commands to it. And so just so you guys know, this is a real Emerson Rock flow computer in our lab that we just pulled up all those parameters, and we just were able to demonstrate that. Now, lastly, very quickly here before we run out of time, is that we will go in here. We can see here we've got a very complex, or not complex, but a large infrastructure. We got 200 devices connected to this broker, 300 to this one, 200 to this one. Well, what about availability and redundancy? What would happen if one of those brokers failed? So let's do that. Let's go into our distributor. We'll go into the configuration, and we're going to fail a third of our infrastructure just by coming in here, going to our distributor, and disabling it. Boom, 200 devices just went offline. Well, now only 170. So because of the Sparkplug spec, all of the edge of network devices know N number of brokers that they can connect to. So what you're seeing here is self-healing in the standpoint that that broker went away, all of our tags went stale, but now those devices are coming back, they're republishing all their tags, and you saw a catastrophic failure in the network basically self-repair itself in just a few seconds. So with that, we're going to end that part of the demo. I'm going to start the presentation back up and hand it back over to Chris.
All righty. So just whilst I'm switching that over, we've got some questions that have been coming in through the chat window. And I'm going to go through a few of these in the last few minutes we've got here. This first one I think is for you, probably, Arlen. The question is, what are the advantages between MQTT, AMQP, co-app, OPC UA, and what are the customer's benefits using cloud with MQTT for IA?
Oh, that's okay. First of all, the OPC UA versus MQTT question comes up in every presentation that we do. We are really very adamant that this isn't MQTT versus OPC UA at all. They both have their benefits. They both have features they can use. I would say that when you look at it from an adoption standpoint, I hope that that slide that I put up a while ago showing the adoption of MQTT is kind of an indicator of how much it's being used, not just within industrial, but across the industry in total. Again, you know, Amazon, Microsoft, IBM, Google Cloud Platform, they all use MQTT technologies. So I think it's the fact that it's very well known. It's definitely more implemented than AMQP or co-app. And I think when it comes to OPC UA, I will have to mention here that in the latest OPC UA release, part 14, their pub sub, OPC UA are adopting MQTT. Now, it doesn't do what Sparkplug does. It's a northbound only connection, but I think that we have to look at implementations, look at what we're trying to do, especially if we're on the edge, and we're going to be using a combination of MQTT and OPC UA as well.
Okay, that sounds good. Another quick question here. I'm new to exploring MQTT. At a glance, it seems to me it's a one-way communication. Can the server know when a device is offline?
Yes, I hope that the demonstration showed that. Again, people look at the fact that MQTT is publishing information. You have to realize that you've subscribed to information as well. So it really is bidirectional. Once your MQTT session is up, then it's bidirectional. You can publish information, you can subscribe to information. So I hope in the demo that I just did, I showed that MQTT is truly real-time bidirectional.
Sounds good. So Kurt, I think this question is probably directed to you. There's been several questions coming in on pricing and costing. Can you talk to that?
Yeah, I can, Chris. So I guess first off, all of the MQTT modules and Ignition Edge, these are all purchased directly from Inductive Automation. So you would not buy that from Cirrus Link, as we're a strategic partner. Any of these modules and the software itself is purchased through Inductive Automation. So if you already have a relationship there, that's where you start. But if you're not familiar with Inductive Automation, if all pricing is available on their website. So if you go to inductiveautomation.com, at the top you'll see a pricing button, and in there you'll find pricing for their Ignition platforms. And then if you go to the next section, which is strategic partners, you'll find a section that has pricing for the Ignition Edge software platform, like Arlen's showing it running on the Moxa box and the Raspberry Pi, as well as all of our MQTT Cirrus Link modules are there as well. So if you go there, you'll find all the pricing. The other thing you might want to note is, if you do have large projects, as we have with other customers, that's, for the Ignition Edge, that's quantity one pricing. There is quantity discounts on that. And again, this can be used on all these other different platforms. So from a standpoint, I'd always go there to look for pricing. As far as being cost effective is a big issue and point here. Like I said, you can just buy one module and get going to the existing SCADA systems. So if you look at the transmission module price there, that's pretty low cost to actually get started. Also, there's a download button at the top of the page as well. So any of the software that you want to test and run, you can download it on a Raspberry Pi, download it on your Windows machine, put it in trial mode and try all this for free. You do not have to spend any money to get going, and hopefully that provides the information you need.
All right, thanks, Kurt. One thing I do want to draw everybody's attention to, in the webinar, there's a handout that you can download. It's an interactive PDF that lets you click on a link and go to specific sections of our online documentation and Inductive Automation's online documentation and see step-by-step instructions on how to download, install, configure these applications here today for no cost. Everything can be run in free trial mode. All right, so I think we've got time for just one last question here, Arlen. How does MQTT Sparkplug handle historical data? Can data be buffered and resent if connections go down?
Yes, part of the Sparkplug spec, we have a flag on any tag that's a historical tag. So if we're publishing that tag, a SCADA system like Ignition knows this historical tag. It's not treated as a real-time tag, and it goes directly in the historian. Other applications like cloud solutions, they probably don't care so much about real-time. They'll just have a timestamp and all the contextual data with those tags. And I will say, Chris, again, I would highly recommend everything that we just showed you today, everything that we just demoed to you. You could download it, install it, and do it today. So nothing we showed you is smoke and mirrors. It's to me, that's the crucial point here. And I really appreciate everybody's time today.
All right, great. Thank you very much, Kurt and Arlen, for that. I think that wraps it up for us. We hope you found the webinar informative, and please look forward to future webinars in this series from Cirrus Link. Thank you very much and have a great day.